Hey, you lovely lot. I'm teacher Jess, and welcome back to Geo Cafe. Joining us today is a very noisy puppy. He likes to remind me very frequently that I need to give him a treat, so you might hear an occasional yap in the background. I hope you're doing well. I hope you have your coffee ready. A while back, I was explaining gradients as a concept, and what I wanted to do today was look at how we calculate gradients. We just want to be able to use it in mapwork. Okay, let me just put my screen up so long. So gradients we learn about as change in y over change in x, or rise over run. Here you go, noisy baby. But I want to approach this with the most simplified version, and I'm just going to use the formula up over across. Loki, what you doing here? Here we go. It's being a very demanding, noisy puppy. You would swear that we don't feed him. We really do. There, you're happy now. You fed. Now you're gonna leave. Okay, Loki, say bye. Say bye. Okay. What you might remember from the last video is that gradient is looking at how steep or gentle a slope is. We compare how far up it goes to how far across it goes. So in one of my earlier lessons, I tried to explain it as steps. These look like quite gentle stairs. You're not going as far up as you are going across. So if we can visualize it like that, and we say that maybe that's steep compared to this, which is more gentle, you can see the basic difference. You can see that there's less up and more across. So that is all a ratio of up to across, right? Loki, if you bring me a toy, I'll throw it. I'm sorry, the constant sounds from the background. He's very cute, but he can also be irritating. So we say gradient equals up divided by across. Okay, so that is going to be our go-to formula. That is what we're going to work. We're going to start with something simple. I want to start with a nice diagram that is a side view. So it's like a cross-section diagram. If that's our hill, we say this is our person. They're going hiking. Yay, going hiking. Okay, and they're busy going up this mountain. And I want to know what is the gradient as they walk up the mountain. The lines are supposed to represent contour lines. So these show us how much he is going up in height. And I'm going to say that the contour lines go up in, let's say, 50-meter intervals. I'm not going to add the units in, or else it's just going to get too cluttered. Okay, so we're going to say 300 was right at the top. We can maybe paint in a little flag, just so we know that he's reached his end destination. There we go. So he's hiking up the mountain. Sorry, he was supposed to start at 0. So he's starting here. Wow, Loki, that was loud. That wasn't necessary. We know you're here. So he's starting at this 0. That's where he's supposed to be. You might recognize these are supposed to be the contour lines. So the contour lines, they show me my altitude. So they show me how high up from sea level he is. And it always increases by the same amount. So we can see that from him to get from his starting point to the red flag, he is going to go up 300. And as he hikes up here, he is going to be moving across. He's going to be moving from this side to that side. Right? So let's just make up a number for across. So let's say he is moving across 1,000 meters. I'm going to add the units in over here because it will actually come around at the end again. He goes across 1,000 meters, and as he goes across 1,000 meters, he also goes up 300 meters. So if we want to find the gradient of his hike, those are the values that we use. I'm going to take this awfully written formula over here. And the first thing that I want to find is up. How far up did he go? He went from over here, the 0 to 300. He went up 300 meters. Then step number 2 is across. How far across did he go? He went across 1,000 meters. So far, we happy? Hopefully. Now we can find the gradient. So for gradient, I'm just going to use G So I look at my up, 300, divided by my across, 1000. There is one little thing that I did skip that I should have actually pointed out. When I get my up and my across, I want to always make sure it's the same units. So in this case, I've used meters. I think it's safely say to always use meters. Typically in the maps that we work with, it's always meters. All of the maps that my students have are always in meters, so let's keep those units. The units are the same, so we can put that into the formula. Then the other thing to know is, now I could simplify this nice and elegantly to 3/10. And depending on what subject you're doing, this might just be your answer. If it's maybe maths or physics or something like that, that's it. It's 3/10. But in mapwork, I always want my answer to be represented as 1/something. So my answer is not complete just yet. It has to be written as 1/a number. My question is, how do we get that 3 to become a 1? Don't say -2. Please don't say -2. You divide by itself. So you take 3 and divide it by itself, and you get 1. 3 divided by 3. And now the law of maths always says what you do on one side, you do on the other side. And in this case, what we do on the top, we do on the bottom. So we divided that by 3, which means we must also divide this by 3. It will give us a decimal, and that's fine. When it comes to gradients, decimals are perfectly fine. Okay, 3.33 recurring. We got this, we're happy. That is how we calculate gradients for this one. Let's try and make this a little bit more difficult. Now, I know there are going to be many maths teachers that might be a little bit unhappy with how I presented this final answer. This is not how you should do it in maths. This is only how you do it in geography. Maybe there's some other subjects that is also fine, but don't do it like this in maths. Don't do it like this in physics. Please, your teachers will be very sad. Now let's try and make this more difficult. I think we're ready to graduate a bit. But in this case, we aren't going to start at 0. We're going to start at, let's say, 700. 800, 1,000, 1,100, 1,200, and then the flag is at 1,300. I realize I'm going to draw a new hill soon, or else these answers are going to start getting a little predictable. How far across do you think he walks? 2,500? I'm completely making up these numbers. I don't think it's like remotely realistic. So let's start with up. Now this is usually when my students get a little bit thrown off, because now is when they would say that up is 1,300. But I'm going to ask it again. How far up did he go? If he started at 700, he started at 700, so he went up 1, 2, 3, 4, 5, 600 meters. If we take top one, where he ends up, minus his starting height, we get the 600 meters. So we can see that he went up 600. And it is in meters, right? It's in meters, so all is good. Step number 2, how far across? That at least is already worked out for us. There, 2,500 across. Wonderful, let's write that in. And that is also in meters. Yay, all is well. So step number 1 was putting an up. Step number 2 was putting an across. Step number 3 is making sure that it's all in meters. That's good, right? Step number 4 is putting it into the formula. We can simplify this to just 6/25. And then we want our answer as a 1/something. So this needs to be a 1, which means that we need to divide both of them by 6, right? And then what we do on the one side, we do on the other side. Yay, the first law of maths. 4.17. Fantastic. All is well. I am happy. Now, I have been giving the answers as fractions. You can also give them as a ratio. If the question asked for this answer as a ratio, you would simply write the 1 first. 1 to 4.17. Okay, I'm going to keep it with a fraction because I don't like drawing dots with the stylus on a laptop. It's difficult. Are we happy with this calculation? Now we're going to do one more that has this side view, and then we're going to change it up a little bit to make it more challenging. No objections. Oh, wonderful. That's what I like to hear. Okay, there's a reason why I'm saving these answers. I want to get back to it right at the end, and I want us to compare the different gradients and see which one was the steepest and which one was the most gentle. Okay, so this is our new hill. They're all supposed to be the same distance from each other. That was so bad. There we go. Picasso at work. Yes, this is absolutely beautiful. This is like the best drawing I've ever created. Absolutely. One thing that I just wanted to make note of is obviously the hill is not a perfect straight line. If you want to be technical, the gradient does change as you move up the hill, and it's steeper and then more gentle and whatever else. In map work, when we're looking at the gradient, we're always looking at it just from one end to the other end, and we're basically just taking an average. So sometimes the question might even ask it as an average. The question might ask for the average gradient from point A to point B. It just means we're working out gradient like this. It's nothing else. There's not more steps. It's not like you have to work out 5 individual gradients and then get the average for it. No, it's just this. Yay, person. Okay, so there's our little hiker going up to the top of the mountain. I hope there's more lines this time. Can you see what I've done? Can you see what I've done? So I've only added in 2 values. I've only added in this one, 200, and that one for 300. And now I'm going to tell you that from there to there, he hiked 3.4 kilometers. So we're going to have to do a few more things to get our answer. The first thing that we need to figure out is what are my intervals. We can see that I put the 200 there and the 300 there. And now we check how many steps are in between the 200 and the 300. So I go up 1, 2, 3, 4, 5 steps. And it went up by 100 meters. So if I go up 5 steps and I go up 100 meters in total, that means that each one of my steps was 20 meters. So each one of my steps is 20 meters. So now we can fill in our missing values. A map won't always have every contour line is labeled. So sometimes they only have every 5th one labeled. Then you just have to work it out. So he started over here at 180. Now we have everything that we need. How far up did he go? He went from 180 to 320. That making sense so far? 140. Step number 2 is we work out our across. I'm just going to abbreviate it to AC. Now he walked 3.4 kilometers across. But hopefully at this point you have a few red flags going off and you realize that we haven't checked off everything that we need to. This is in meters. Fantastic. But this isn't. That's not good enough. We need that to be in meters. So to convert from kilometers to meters, we have to times 1,000. Now I'm happy. Now my answer is in meters. So my gradient is my up 140, oopsie, over 3,400. I'm actually just going to jump straight to the final answer of 1 over something. So we want a 1 over something. And to get that, we need to divide the top by 140 by itself, which means we need to divide the bottom by 140 as well. Let me do calculator things. Okay, I've got 24.2, I'm rounding up to 29. Okay, are we happy? So question C. Now, I said that I was going to check which one was the steepest. So we have our 3 little options, and now we wonder which one is the steepest. Remember I said that's steep. Let's just redraw those stairs very quickly. Steep is a lot of up and a small across. Up and a small across. And then gentle is smaller up and a lot of across. Now all of the ups are the same. They're all one, which means that all that we compare it to now is the across. Where you have a small bit of across, it's steep. Where you have a big across, it's gentle. So this one, our first one, A, has a small across, which means it's the steepest. And C has the biggest across, so it's the most gentle. What I wanted to do for the last part was I wanted to see if I could find a more map work style question where you can see why I've been doing it with these contour lines looking at the side view. Now we're going to find a question that has contour lines but from the top view. Can you guys see those numbers? Okay, yes, you can see those numbers. Should we do A to B or C to D? You're saying A to B. Okay, let's do A to B. That's 9 kilometers. Okay, so first I need to find up, then I need to find across. So my up, I'm going from A up to B. And if you notice, A is on the coastline. So over here, this is the ocean. A is lying on the coastline. So it's lying on this line over here, and that's 0. So it's 0 meters, which means that if we're going up from A to B, we're counting from 0 to 300. You see that the dot is on this line? That's the 300. Up is 300 meters. Is that making sense so far? That's pretty much as complicated as it's going to get. And then I just measured the across for us. So the across is how far forward we walk from here to there. So that's our across. And I just measured it and I found that it was 9 kilometers across. If you want to recap on how I did that measurement, we can go back to scales at some point. I'm happy with the up. I'm not happy with the across. Do we know why? I'm sure you do. Because it's in kilometers. Okay, so I need to times it by 1,000. And then I get, now I'm happy. And then finally we work out the gradient. 300 divided by 9. Is this going to be our first one that doesn't use a decimal point? It looks like it. Okay, what is that? That's 1 over 30, right? So we want the top value to be 1. So that's 1 over something, which means that we divide this by 300. And we divide this by 300. That's 30, right? 1 over 30, which means that this is the most across. So it's the gentlest. Is this making sense? Do you think you feel confident in how to read a map and get the gradients from there? This was just focused on the calculations with the up and across. When it comes to actually measuring the across, that is a whole different skill set. Often it's its own question completely. So in exams, you actually first have a question that says, measure the straight line distance from A to B. And then you get marks for doing that and you get your answer there. And then the next question is, find the average gradient from A to B. And then that's a separate question, and then you use your previous answer as your across. I hope you have a lovely day. I hope that you learned something, maybe had a few questions answered, and I hope that I'll see you again next time. Have a lovely day. Have a lovely day. Cheers. Bye.